Hello, everyone. My name is Cody DeArkland. I work for Kong, and yeah, thank you for joining us for another week of Kong Builders. So, for those who your first time joining, welcome. We're a fun community who likes to just do nerdy things and build cool things with the Kong products. So at Kong, I focus on service mesh, and so a lot of what we do on this series right now is service mesh. But I know that last week, might have been the week before that, Victor from our developer advocacy team had joined, and he did a really cool session around our Connect platform and Kubernetes. So we're branching out beyond just service mesh, but just to kind of set the stage of what we're going to do today. A couple weeks back, we had started out this series with building our service mesh from the ground up. So in that session, we had gone through and we built our service mesh. We deployed Kuma inside of a Kubernetes cluster. I'm using EKS in today's video, so shout out to the Amazon folks for having a great Kubernetes platform. So I'll be building in there today. We've already got Kuma up and running, so we're not going to run through that whole setup process again. I'd encourage you to subscribe to the channel. There's videos in the Wayback Machine around how you can get started installing Kuma from the ground up. So we already have that installed. I'll bring it up in the UI. We'll take a look around just so we can understand kind of what's in that environment. In that original video, we went and deployed our app, deployed the gateway. We did all that stuff. I'm going to do that again today just to kind of reinforce some concepts. And then we're going to jump into just playing live with some policy stuff. We're going to start doing some traffic permissions. We're going to explore how we can set up kind of that zero trust model inside of service mesh. We talk so much about policies in service mesh and this idea of kind of apply it once, consume by many. Today, the goal of today is to get through that. If we manage to just wreck through that at warp speed, we'll probably jump into some observability stuff. We'll maybe play with a little Grafana metrics action. Formally, that's scheduled for next week. But I like to have in the back pocket in case we move fast and things aren't breaking like we typically expect them to. So I've got, if you see me, just for the audience out there, if you see me turn this way, I'm looking at the chat window so I can answer any questions that come through from anybody in the audience who's watching. If I'm looking this way, it's because I'm looking at the screen and we're dialed in and we're playing in the product. So I just want you to know if you see me bouncing between, it's because I'm trying to be attentive to everyone's needs. So let's jump in and start playing. Let's fire up sharing. As sharing comes up, I just want to shout out, there's a couple people behind the scenes helping orchestrate all this and get it going. Taryn with our developer marketing team, and then Michael, who leads up our developer advocacy team. So thanks, Taryn and Michael, for always helping me look as best I can. It's a huge challenge, and you do it really well. So thanks a lot, guys. All right, so here we're in our UI. I go ahead and so I use a lot of aliases, so I'm sorry for that. It's just how I roll. KGP is kube control get pods. We'll do get pods also. We can see kind of the lay of the land for our cluster here. I've got Kuma up and running. We'll go ahead and pop into that. I'm actually going to use a separate tab. Just to break down what we're doing right here, we're using kube control to port forward into the Kuma system namespace, and we're going to hit the actual control plane service. That control plane, I kind of broke this down in some of the other videos, but a quick just recap on it. In Service Mesh, we talk a lot about control plane versus data plane. Control plane is where administrators and operators interact with the Service Mesh platform. It's also where policies are pushed down to data planes. Data planes handle user traffic and communication within the mesh. So there's a big difference there between how control planes work and data planes work. We use Envoy as our data plane. So we're pushing configurations into Envoy and letting Envoy handle user-to-user communication within service-to-service communication is a better way to say it, within the service mesh. Control plane is how we orchestrate those configurations. All of the meshes typically work on a control plane versus data plane model. A lot of the differences you see in service meshes comes down to how that control plane is implemented. So we focus on a couple of things specifically in our control plane, things like multi-cloud, operator experience. How do we make it a platform that you can get up and running with quickly? All that goes into how do we push configs into the data plane so that you can actually consume them. So in this case, I'm going to port forward to the control plane, which is going to give me access to the GUI. And so we can see kind of what's happening inside of that environment. So we're port forwarding in now. We'll switch over to the other window. And we are into the UI. So running Kuma 1.2.1, that was a new release that just came out last week. A couple of fixes in there. We also did a live stream about 2 weeks ago, 3 weeks ago, where we kind of featured all of the 1.2 features. We're going to touch on quite a few of those today also and revisit them. A couple things just to call out, high level stuff that we broke down in the other stream, but I want to make sure that anyone who's joining for the first time kind of gets where we're at. A zone in Kuma and Kong Mesh is a workload location. So that might be a VPC in AWS. That might be a data center in vSphere. That might be some form of a zone, right? It's a place where workloads live. So we're doing standalone mode. In a couple of weeks, we're going to dive into multi-cluster and we're going to start playing with multiple zones in the same service mesh. Right now, we've got one zone. Our zone control plane is running version 1.2.1, which is the version of Kuma we're playing with. No services, no data planes, no envoys, no proxies yet. It's a pretty empty environment. We have the ability out of the box to be very multi-tenant in Kuma and Kong Mesh. So we have the ability to, I mentioned earlier, Taryn and Michael are on the call with me. If I was a mesh administrator, I might create Taryn her own virtual mesh. I might create Michael his own virtual mesh. We can all have independent configurations, independent policies applied, really operating under that same mesh. So we focus a lot on making multi-tenancy a consumable thing in service mesh. So that's a big thing that we care a lot about. So when I'm looking at this mesh here, I'm seeing that this mesh is set up. MTLS is disabled. All of these features are disabled. We're going to turn some of those on today so we can play with traffic permissions. So MTLS will go on. Right now, we've just got the default policy there. So let's get started. Let's deploy out our application again and get things rolling. But first, I want to start highlighting some of the new things that we added recently. If I switch back into the CLI, and I'm going to make sure Kuma control version. Cool. So I'm running the Kuma control version 1.2.1, which has all the new hotness, new features in it. Out of the gate, I'm going to install our Kong gateway so that we have kind of an ingress path to get to our application. So I'm going to go Kuma control, install gateway, Kong, and I'm just going to hit enter so you can see kind of what happens. So what I get output here is effectively the YAML, which we're not going to decompose in this call. But I get the full YAML of what this deployment actually does in the environment. So what we're doing is we're spinning up the Kong proxy, we're spinning up the ingress controller, and then we're setting up sidecar and just different configurations within. So once again, I'll run that command, but this time I'm going to pipe it into kubectl apply F and let it deploy into the environment. If I do now control get pods all, we can see that coming up. I'm going to spend a few minutes explaining kind of what's happening here, mostly because if I go in and do a kubectl get services all, we see this address here. This is going to take a little while to come back up. AWS Elastic Load Balancers are heavy. They take a little while to fully register with Route 53. AWS is a DNS provider, so it takes a little while for us to be able to access it. It's a good time for me to ramble on kind of what's happening inside of the environment. Switch back to the UI real quick, and we will go in and we'll just toggle between these two real fast here. I need to take this feedback that I'd love to see a refresh button. So I might, what would be really cool is if you have any feelings, like, would you like to see a refresh button on the overview page so that these values update? Like, I think that's a cool feature. It'll be a cool, like, nice little quality of life. If you think that'd be interesting, drop a comment in. Let us know if you think that would have any use to it to refresh this page without having to just toggle between. Either way, we see a data plane proxy online. If I click on this, we can see Kong ingress. This is registered. Green typically means good things, so we can see it's connected in the environment. Something I love that's like a small feature that we do inside of Kuma and Kong Mesh. I've worked with several service meshes over the years. I love that we show the updates that are coming in to that data plane object, because that, for me as like an operator, that tells me that things are happening. It might not be working, it might not be doing all the things I want it to, but if I'm seeing this total updates number go up, I know it's getting configurations from the control plane. So it's one of those like small quality of life things that I really like. So that's there. If I go into gateway, we can see I have a gateway configured now. As I mentioned before, we deployed out Kong Ingress Controller. This gateway it has what's called gateway mode enabled. Gateway mode enabled means it's turning off the external Envoy listener. This is a really complicated concept to break through. Um, when we attach a sidecar to a application inside of Kubernetes, we the Envoy sidecar takes over all communication, so inbound and outbound. Gateway mode turns off the outbound listener, so it allows user traffic to just come in and hit that, and then outbound traffic goes out through the outbound listener on the outbound communication on the Envoy sidecar. So gateway mode is how we integrate with any gateway in Kuma and Kong Mesh. It's a really powerful feature if you don't want to use Kong Gateway or Kong Ingress Controller. Why would you want to do that? Why wouldn't you want to use Kong Gateway? But all jokes aside, really powerful feature for integrating with other systems. In this case, it's tied in, gateway mode's on. I can hit this proxy as soon as the load balancer comes all the way up. Go ahead and get our application deployed now. I'm going to hop into the actual configuration for that app and just talk through a couple of quick things. We're creating a namespace. I'm just calling it Kong, not for any reason, just calling it Kong. We're turning on sidecar injection enabled, which means any pod deployed into this namespace is going to get that sidecar. This config map down here is just a bunch of application configs for the app I wrote. There's nothing special about Kong in there, with the exception of these values here, where I'm using this .mesh address. We use a form of DNS. We use core DNS inside of our clusters to send traffic that has a .mesh address through Envoy. So this is how we kind of enforce that Envoy should be used for communication inside of the mesh. It's going to send traffic through that when you use that .mesh address, especially for systems that are going outside of your local zone. If I was working in single zone, which I am here, and I took off that .mesh, it would still work. It would go through Envoy still because it's a single zone. I tend to default to doing .mesh just to always send it through, whether it's multi-cluster or not. You don't need to have the .mesh there in a single zone configuration. I have it there. It doesn't hurt. So that's an important thing to know. We added functionality in 1.2 to where DNS is always turned on. You used to have to do a Kuma control install DNS to turn that on. Then them's days are gone. Rest of this is just configs for the app, nothing terribly special. A couple of things in here that'll come up later. I have some Prometheus configs here. Those are going to tell Prometheus to scrape this pod for metrics when I do observability down the road. I just leave that on for grins. I've got some service configurations here. I'm telling Kuma that this is an HTTP service. So it lets us turn on what are called the layer 7 features. Typically by default, communication is just based on TCP. So it's like, hey, are you there? Yeah, I'm there. Let's send traffic back and forth. When we turn on that HTTP functionality, we're able to start looking at the context of the request coming through. That HTTP listener is online and it's looking for HTTP traffic. You wouldn't want to turn this on for a database, right? Because the database is only going to answer on a TCP connection. It just won't work right. So in this case, our front end is a React-based front end. We want it to be an HTTP service. We want to be able to get tracing out. We want to be able to use the layer 7 routing features. So we're turning this on via an annotation. That's the only thing that's worth mentioning. Again, our API is an HTTP service. We're turning it on there as well. Those are the big things. I'm going to go ahead and apply this policy now. All right, so that is going to come online. It's going to take a few moments to come up. So I'm going to do a kubectl get pods, and we'll do a wait. So we're going to let it wait for the system to come online. Just took a look at the comments on the side as this is coming up. Awesome. Hi, Matt. I see your question there. Do we have an example on how to communicate between meshes? Absolutely. That's not in this stream. We are going to cover that in a couple of weeks, but I can answer that very, very quickly as this stuff is coming online. You'll see a live demo of that little ways down the road when we get there. So you heard me talking just a moment ago about that .mesh address on the end of this. What ends up happening, if we have, so let's pretend for a second that we have two clusters. We have an Amazon EKS cluster and an Azure AKS cluster. We've joined these in a global service mesh. We have a global control plane where these two meshes are joined to that. The envoys or the sidecars between those environments are going to look for something called a zone ingress. That zone ingress is a mesh-wide concept that lives inside of those environments and acts as a front door for mesh communication. So I, as a user, can't connect to that zone ingress and hit a service. But what will work is when the mesh tries to hand off traffic. So I have my front end in EKS and my API in AKS. And when my front end goes to talk, it will actually reach out to the zone ingress in the AKS environment, and that will then hand off. That is enabled by using that .mesh address on the end. What'll happen when you use that .mesh address is it'll contact an Envoy VIP, a virtual IP that Envoy's created, and then Envoy will look at the SNI headers on how to hand that traffic off to the other environment. The control plane is what dictates where those things are. So as systems come online, they report up to their zone control planes, and then their zone control planes send that up to the global control plane. Global control plane keeps track of where everyone's at, understands, like the post office, right? It understands how to put things on a truck and get it to your actual house. That's what that global control plane is doing. So the letter goes out from your house, goes to your local post office. Your local post office says, "Yeah, I know where this person lives. I'm going to send this over here." They go to their local post office and then hands off to the actual service. Again, that's enabled from a technical perspective. That's enabled by turning on MTLS. So first you have to set up the global service mesh. So you build a control plane, build two remote control planes, connect them all together. Just maybe 4 or 5 commands total. You turn on MTLS. We turn on MTLS because that gives us the SNI header that lets the mesh know where traffic needs to go. When you've deployed those meshes, you've turned on a flag that says ingress enabled, and that's going to turn on the zone ingresses. And then by making sure your application is configured to use this .mesh address, sends that traffic back through the mesh and over those zone ingresses. So we'll do that hands-on again, like next time, or not next time, but either next time or the time after that. But at a high level, I think that explains it. If you have more questions on it, you want to unpack it more, drop those in the comments. We'll dive deeper on that in this. We should have time to very easily cover that as well. Can't do it practically in this one because I'm not set up for the multi-zone right now. I just haven't built out the other cube clusters that we'd use. Our app's up and running. We've got our ingress. And if we go and hit our I don't know why I did that command. I totally went out of order there. We have our ingress gateway here. We'll hit this address. Oh, that showed up on another screen unintentionally. So I'm going to cycle this and drag this over so we can see it here. Now, this is not going to work, just a spoiler alert a little bit. If I go advanced and tell Chrome that I trust this anyways, no route match these values. I haven't configured the ingress to use or to reach out to anything yet. The ingress is just there. I have no ingress entries. So what I'm going to do is I'm going to get back into the command line. I've got these stashed away over here. There's two things you need when you're configuring the Kong ingress controller to work within the service mesh. You need to create a Kubernetes entry file or Kubernetes entry that will point it at the mesh configuration. So it's saying, hey, go talk through the service mesh in this case. So it's saying talk to the front end's mesh address. So we're going to go ahead and create that. And then we are going to create an ingress resource. This is just a Kubernetes ingress resource. We use the standard Kubernetes ingress spec. And what we're saying is name it demo, put it in the Kong namespace, use the Kong ingress class. Anything that goes to / send it to the service we created. You would typically just include this with your application. I have it broken out here because I'm just showing it through the path, but you typically just include these in the application, you apply the app, and all this is configured for you. So let's go back in, let's refresh, and with any luck, everything comes alive. So the way this application works, and I got this feedback from the previous session that we kind of went through this and had no one had any idea how the application's configured to work. So it's like the context is kind of lost. Good feedback. So I want to step through kind of what's happening here. So this is a React-based front-end application. So React.js, just a popular web framework. It's hosted in an Nginx container. That Nginx container has several reverse proxies configured in it that are pointing to other backend systems. So when I go to /API/posts, it sends it to this service. When I use /API/users, it sends to this service. These things communicate with both the Postgres and the Redis databases to do stuff and things, right? You can't have a demo these days without a Redis tier, and who doesn't like Postgres? So the general flow of the application is user comes into front end, user tries to log in and goes through the user service. Once they're logged in, they can post messages to the API, either via the API commands or via the UI. When they go to post, it uses the post service. There's a WebSocket running to show the actual web service information, or I'm sorry, the web service information, the posts in the chat that shows up, the message board that shows up inside of there. And that's continuously pinging that post service for updates or receiving updates from that post service, which is in turn getting it from Postgres. So it's kind of a 5-tier application that shows communication across the board. If I log in here, my super secret password, that comes up. Welcome admin, things are good. Hey y'all, hey, things is working. Just for grins, we'll drop this into the chat. Drop this into our backend chat, and if everyone wants to share that out, if people want to hit this, they can. Try to break it, or if you break it, we'll have to figure out how to fix it. So that'll be kind of fun in its own way too. So that's up and running. Do with that as you will. So we are up and running now. Everything looks good. We can actually start doing some mesh configurations now. Right out of the gate, I know that I want to turn on MTLS in this environment. I want it to be encrypted. So what I'm going to do is cat out our MTLS config. Policies. Oops. So this is a policy YAML. So this is going to be applied to the Kubernetes cluster. It creates a CRD. We can see that CRD is part of the Kuma.io API. What we're doing is updating the mesh CRD with these values. So we're turning on MTLS. We're telling it the name of the backend, giving it the details of that backend, expiration dates, configuration items. So as soon as I apply this file, the traffic is now encrypted between. So out of the box, without really changing anything in the app, we automatically get MTLS encryption between the services. Traffic is now encrypted between the front end to the API back to database. Everything is encrypted at this point. We can verify this by going into the UI once again, hitting meshes, and we can see MTLS is now enabled in this environment. You can see I have commented out in that file some tracing configurations. If we had the metric stuff installed right now, we could turn those on as well. Obviously, we're going to get to that at a later date, so that stays disabled for the time being. So MTLS is on in the environment. We're good to go on that front. Let's start playing with some traffic permissions. If I recall correctly, this is where we broke things at the end of the first stream. I went in and was clearing out some existing permissions, and I deleted the traffic permission CRD entirely, which means the CRD was now gone, which means we couldn't apply traffic permissions anymore. I broke that by doing this command. Which would clear out that entirely. That is not the right way to do it. My brain wasn't firing right that day. What we want to do because if we go in and we look at the traffic permission policy, by default we create and allow all so that we don't disrupt traffic. So if I go back into the app, everything's talking, life is great. For the record, if anybody wants to post, the user and password is admin admin, so it's not anything terribly secret. So you can go in and mess around with that. But what we'll do here, we have this allow all policy by default that's saying any service talking to any service is allowed. If I go in now and I do a kubectl delete traffic permission, allow all default, and switch back in a few moments, everything should get very sad. Things aren't working anymore. If we try to go in and look at configurations, those configurations are not registering because traffic is blocked. So now the local Envoy sidecars don't know about each other anymore because they're not getting the right filter applied to get communication data. So we're disconnected. Life is sad. If we were looking in the chat or in the console logs for this, we'd see a ton of 502 errors where things just aren't working and we're getting bad requests. So let's do things what I call the old way, which is where we apply a set of permissions based on service name. We go in, we take a look at our standard proxies. We can see we have these different service names for each of these services. So post service underscore Kong underscore service 5000. What this breaks down to is the name of the service, the namespace it's in, SVC for service, and then the port that's used. That name is automatically generated. So we can use that to kind of go through and start to configure out how these work. It's important to think of like the architecture that we're working with here, though, right before we get started. The traffic goes from the front end to the API. However, there's a key part there to remember. We installed an ingress gateway. So traffic is actually coming from user into the ingress gateway. The ingress gateway is handing off to the front end, who's then communicating with the other components. So when we create our permissions, we need to start at the gateway side. So if we go into gateway here, we're going to use this service name as the initial outbound communication. So let's pop back into our CLI, that one. We'll head into traffic permissions, and we can start to play. So we'll name this gateway front end. We'll switch back to the UI real quick to grab the right name. Every once in a while, our port forward gets a little squirrely and we just have to restart it. Hey, the internet's fun, right? Things break sometimes. We're back, I think, at least. Let's go ahead and get our sharing back on. Sorry about that, everyone. I had a nice little blip there on the old Comcast. Back in the game. All right. We're gonna get back into our port forward that dropped. We will refresh our UI. Back off to the races. Okay. So we're going to grab the service name for this, right? This Kuma IO service here. And that is what we are going to filter off of for the source service. We need our destination to be configured. So that is front end dot or underscore Kuma underscore SVC and then 80. So we'll apply that traffic permissions now. Go in and take a look at our traffic permissions. We should see that in here. Gateway to front end. There's the YAMLs. If we refresh this, it should load up. Should load up. And it takes a few for the policies to push down, so we should give it some time. Make sure everything's actually in there. Yep, everything looks good there. Come back. Come back, please. Continue building out our policies while we wait for this to refresh. I think that my little internet drop there has had some impacts downstream. So what I'm going to do now is I'm going to copy out and create another version of this file. So we'll go copy traffic permissions. What we'll do is we'll call this next one. What we'll do is we'll go, got a folder for these, I think. Step by step, and we'll call it front end users.yaml. Once again, we'll come in here, change this to front end on SVC 80. Make sure that I have the service name there correct. So front end Kong SVC 80. And then we'll send this to postservice.kuma.svc 5000. That's applied. Up here, let's refresh this. A little bit of a weird hiccup there. I'm going to reapply that policy. I'm going to make a quick change to it just to simplify things real quick to make sure I'm not handling that wrong. We're going to tell Kong proxy that it can go anywhere. There we go. Cool. So we should have our policy coming online now. If I go in here and I look at the post service, okay, so it hasn't updated yet either. We go and look at certs, can't see anything yet. So that's just taking time to come back to life. Now, what's interesting about this is we can go in and we can start to see these configurations kind of somewhat happening live. If we go in and do a kubectl get pods all, and we port forward into our actual front end container, we can actually see kind of the live configuration of Envoy by curling the local host 9901 and hitting the clusters API. So we can see this is the service name that's there. So it knows about this service now, the front end does. But you'll see like nothing else is showing up in here. Actually, user service showing up there. So that's good to see. And then we can see the front end service as well. So things are showing up. That's a good sign. You can see total requests. We got a fair amount of errors coming through as it's trying to communicate because the traffic itself is blocked. some reason though, that traffic permission policy hasn't kicked in yet, which is a strange one. Oh, that's weird. We have I see what I did wrong. I didn't rename the file. Oops. So Vim, traffic permission, or step by step, front end users. Do we have this gateway front end here? So let's change this name to front end posts. There we go. Refresh. Starting to cook with fire now. While that comes online, we'll also go back and configure our permissions for the it's funny, I called that front end users and it should have been actually front end posts. So that's a mistake on my side too. We'll go posts database YAML. We'll go posts postgres.yaml. Post service. On SBC 5000. Going to DB5432, which is going to give me the Postgres communication. Then I need to do another one for the post API to the Redis database as well. So I'll go and apply that one as well. It's weird, right? Oh. I feel like I have done something strange as far as where I'm putting these files at. Oh, oops, I didn't copy that file first. I just vimmed straight into it, which is kind of a weird path to do. We're gonna short circuit this actually because I'm gonna create like 11 different files to do this, and that's not a fantastic demo, anyways. What I wanted to show at the end of this was like we can do traffic permissions in this way, where we're going through individually and creating service to service to service to service. That's one path to do this. Another path is for us to look at using some of the new functionality we've added in the most recent release, where we can start to do traffic permissions off of other characteristics of the application. For example, we can use these labels. So you can see I've labeled all of these with group demo app as a value on these. If I go in and run that same command against the local pod against certs, these are all things that we can key those policies off of for communication. So I can do group demo app or Kuma.io group demo app as a valid policy, or a valid source and destination rather. So what I'm actually going to do now, oops, so I'm going to edit that other policy that I created, that permission step by step. I'm going to create a new one that we'll call permissions moapp.yaml. What we'll do is we'll go allow demo app. And instead of Kuma.io service here, we're going to go switch back in and we're going to use group demo app instead. Should be able to go group. Remember, right? That should be how it works. I'd have to throw a Kuma in front of that in order for it to do it. Now that I'm thinking about it, what we'll do just to make sure, since we're doing this live and I'm doing it from memory, we can do something that we should all do, and that's read the docs when we're not fully certain. So we'll go into policies, or will we? Traffic permissions. Just checking out the chat to see if there's any questions in here. Everything's looking good. I'm going to the traffic permission policies. So we see external service. There are the service policies. There should have been one in here for using other tag data. Into list. Let's see, why is it not listed here? That's a strange one. But that was the next. So that's a good one to capture in docs later. Let's see what happens with that policy applied. I'm gonna delete the other one since we don't really need that anymore. Was never applied anyways. So get traffic permissions, all. So we have allow demo app front end posts, and that's we'll go, okay, delete traffic permissions, front end. We'll leave the gateway to front end policy in there because we need that in order for the gateway to work. That reason that's not working now. Let's go check out the traffic permissions real quick. This is the fun of fixing something live. Let's refresh just to make sure we're getting the most recent config. Kong proxy Kuma gateway service 80. In there. Allow demo app is match group demo app to group demo app. Might not be group, might be Kuma or Kuma group that I'm doing wrong there. Give it a minute here to come up. Double check that things are coming up. This is a solid demo fail, y'all. Let's actually start from the ground up. Let's go back one. Spin into our traffic permissions. Make sure that we're getting all traffic through real quick here. Make sure that everything else is actually working still. The problem is that I used the wrong. I think I used the wrong nomenclature here because I think it's actually supposed to be. So the traffic permissions are tied to the cert configuration. So in this case, I think it does need to be Kuma slash group in order for it to actually work. Although it's kind of strange because these ones would be Kumayo service, so it should actually just be group now that I'm thinking about it again. That's a weird inconsistency. I'm going to need to dig into more, I think, in order for this to work. Okay, our app is back. Let's make one more change again and see if we can get this actually communicating the right way that we want to. Double check something real quick, make sure that we're actually using the right. Oops. Gateway service. 80, cool. TCP, cool. Any service, cool. I'm gonna refresh this a few times to make sure that we're consistently getting through. Great, we are. We go in here, we should see nothing coming up because communication's not allowed down to our post service. Okay, that's done the right way. Let's go double check this file real quick. Fix this to actually be front end to posts. I'm kind of rewinding a little bit so I can just double check to make sure we're doing things the right way. Front end on SEC 80. Post service on SVC 5000. So let's try some. Let's go API posts DB. Okay, so we are reaching through right now. It's showing down because the database traffic's down, but this path goes through the API or the API to post. So we are communicating successfully between. So the traffic permission is working now. So let's go permission step by step. Users, which is the wrong name, but we're in it now. Let's to database.yaml. Create both of these files real quick. Post to Redis YAML. Post service. Going to DB on SVC 5432 for Postgres. Oops. So that's there now. And then we'll also do Redis SVC. I'm blanking on what the Redis port is. So that's my mistake. 6379. Hop back into the UI now. We'll go traffic permissions, gateway up and running, sending traffic, front end going to the post service, post going to the database. Live looks good there. Database is up. So we can see that changed. I think we're in business now. Cool. So the first part is up. We should do one more and we can have the user service up and life will be good and we'll be back on track. First we need to do move permissions, front end users to be permissions, front end posts. That was named wrong. Actually, what we'll do is we'll do a copy. And then we'll go on users. Users, user service rather. Going to user service 5,000. In moments that should pop up. Actually, I need to do one more permission for users going to Postgres in order for that to pop up correctly. But if we come up here and we do API slash user slash DB, we're able to communicate with it. So we're getting to the API, it's just the database is down. So if we do one more, thank you for going on this journey with me. And we go that one and we call it user database.yaml. Database is up. Kind of flake for a few as everything kind of reconciles back across like those different permissions. So that's just a little bit of a false negative there. It's more of a UI problem than a communication problem. But if we come in, we can see we're now getting connectivity all the way through. So that's a good sign. Life is good on that. If we go back in here, we can see all of these different permissions actually, or all these different policies are actually applied now. If we go in and we do a get traffic permissions, all these all show up as CRDs individually in that environment. So we're cruising up on end of time. So unfortunately, I'm not going to be able to get to actually setting up some of the traffic policies we wanted to touch on. So we'll have to cover those next time. And the next time we'll also show how we can move to that tag model where we're using kind of one tag lets us logically group applications better together and traffic permissions. Words are hard. So we had a little bit of a learning experience on this one as we corrected some policies that were named poorly on the fly. So that's my apologies. But it's good to have these things fail live and you get to walk through and troubleshoot why they're not working and fix them. So next time, again, we'll come back in, we'll group these up and we'll show how you can use these labels in Kuma and Kong Mesh to group things together. So it makes it easier from my perspective when you say, hey, these are all part of the same demo app. They should just all be able to talk to each other. And then the gateway handles communication inbound. So that's something we'll handle next time when we come back in 2 weeks. So I want to pause now with about 5 minutes left and answer kind of questions that come up in the comment section. So any questions from anybody? And we can do this on anything at all, anything Kuma Kong Mesh related that's outside of, or that even outside of this walkthrough that we did here today. waiting for them. I'm seeing nothing. Going once, going twice. All right, everyone, then we are going to sign off on this one. Next time, I promise we will get much further, much faster. So I appreciate you coming to hang out with me on a Friday. I hope everyone has a great weekend. If you're in California, stay out of the heat. It's miserable out here. It's going to be like a 108 today, 113 tomorrow. So stay inside, stay safe. Again, thanks, Tara and Michael, for all the help on the back end, especially covering me when my internet turned off. You guys are gems, and I appreciate you. So take care, everyone. Have a great time.